Good people, sanibonani, uMakebalo. Today we are doing question 3 from November paper 2019. Remember, this is a grade 10 paper, so we'll be doing the question 3, which deals with the trigonometry in grade 10. Now, let's get into it. Here, in 3.1, they're saying if my x is 37 and my y is 44 degrees, let's calculate this, or let's calculate the value of this thing here. So if it's sine squared, they tell me that my x is 37, so it's just 37 degrees, and plus 2 into its cos y into 44. Now it's very important, punch this in your calculator and then get an answer. The answer that I got is 1,80. This is just simple 1 mark. Just punch, substitute punches in the calculator. Now 3.2, it's saying without use of a calculator now, let's determine this thing that we have here. Now, first thing here, because the others we could just gonna punch our calculator, or you need to know your special angles. But what is very important here is this chord, because chord, you can't find chord in your calculator. Now you need to remember that chord is what is 1 over tan. So it's going to be 1 over tan 45. So from here, now sine 30, we know that sine 30 is what? Is 1 over 2, and then times, now cot 1 over 45, it's going to give us what? It's going to give us 1. And then all over cos 30. Now cos 30 is going to be over 3 all over 2, and then times tan 60. Tan 60 is square root of 3. And now from here, simplifying this, okay, 1 over 2 times 1 just gonna give us 1 over 2. So now what is happening here, I hope you can see now this thing here, it's over 1. So it's gonna be square root of 3, square root of 3, which is just going to give us 3, and then 2 times 1, which is just going to give us 2. Now, I'm having these two denominators now, so this is just 1 over 2 divided by 3 over 2. Now, reciprocal of this, changing this is 1 over 2, is just going to be 2 over 3, which is giving me these two and these two, they're gonna cancel each other, so my answer is just gonna be 1 all over or 3. I hope we're on the same page there. Now let's go into the second part of this question. Now okay, now doing 3.3, it's saying in a diagram below, a triangle ACD is a right angle triangle at C. So they're telling us this is a 90-degree, which is a right angle triangle, and E lies on AD. So E lies on this line AD, such as that CE, where's my CE? CE is perpendicular to AD. So this be perpendicular, meaning this is 90 degrees, and also this is 90 degrees. Now let's go into my question. Now 3.3.1, they're asking us to write down the ratio of cos in a triangle ACD. Let me first highlight this triangle that they are talking about, A, C, D, meaning this is the triangle that they are talking about here. So the angle that they're specifically talking about, they're talking about this angle of D there. Now remember, now D, of course, it's saying adjacent over hypotenuse. So this angle here for cos is an opposite side of cos. Remember, this is my 90-degree, meaning this is my hypotenuse side. So this is H. This is an opposite side. Automatically now, this one is going to be the adjacent side of this angle of cos. So cos of D is going to be, remember, because it's adjacent, so my adjacent side here is DC all over hypotenuse side. Hypotenuse side here is what? Is AB. So this is going to be the ratio of cos. Now, going to the ratio of cos D in another triangle. Now, let me get some new space now here. in order for us to highlight this second triangle that we're talking about. So we're talking about C, E, D. So this is the triangle that we are talking about, and we mustn't forget, remember, this one here, it's also 90 degrees. So if this is 90 degrees, this is going to be my hypotenuse side. Then remember, this is the angle that we're talking about. So this is in the opposite side of the angle D, automatically my adjacent side now. So remember, hypotenuse, opposite, and then my adjacent is going to be this one. So what is now the cos? So cos of D in this specific triangle that we're talking about, this is 3, 3, 2. Cos of D now adjacent. So adjacent in this side is ED over my hypotenuse side, which is what? Which is DC. I hope we're on the same page there. This is very important, specifically to the question that we're going to do right now. Here in 3.3.3, they are saying if AD is 13 unit, now let me get some space so that I can fill all this information here. So if ED or AD, where is AD? AD, this whole side here, it's 13 unit, and DC, so this one here is what is 5 unit. Let's find let's calculate the length of OED. So they are looking for this side here of OED. Based on what is happening here, remember these two, cos of D and cos of D, they're equals to this. So I can say automatically OD C all over OAD is equals to OE D all over DC. Why I'm saying that? Because both of them, they're equals to the cos of D. Now here, remember, we are looking for OED. Now cross multiplication here is going to give me OA D times OE D is equals to this and this, they're going to be DC squared. Now, remember, I'm looking for OE a D, so I'm going to divide by OAD both sides. So I'm going to be left with OED, which is equals to DC squared all over OAD. Now, doing my substitution, now my DC, it's 5, so it's 5 all squared all over my AD, which is 13, so it's 13. Now getting an answer there, it's going to be 1,92 unit. So this is the answer that we're looking for OED. Now going to this one now, 3.4. It's given that cos is now cos is equals to 5 over 13. Remember now, cos is an adjacent all over an hypotenuse. Remember now, adjacent is an x, and in terms of x, y, and r, and hypotenuse is an r. Now here they are saying the restriction that they want to tell us is that sine theta is less than 0. Now, which means that sine it's negative of 0. Now, drawing the diagram now, because we need to draw a diagram in this type of a question. Where do we get sine negative? Remember now, sine is positive here, and also sine it's positive here. Then sine is negative on this quadrant and also on this quadrant. Now, so the diagram that we're going to draw, it's either between this diagram where sine is negative and also this quadrant where sine is negative. Now, again, what is very important that is going to direct us in terms quadrant are we going to use is what I just wrote here. So my x here in terms of the adjacent is positive, and over here see the hypotenuse ways what it's always positive. So but here in the fourth quadrant, if I can draw my diagram here, I hope you can see that my x value here it's negative. So automatically this diagram can't be here because my adjacent side according to what I have here is what is positive. So automatically my diagram needs to be here on the fourth quadrant. I hope we understand that part. That is very, very important. So my diagram is going to be here, which is this angle of theta here, and now doing my values. So this is 5 as my adjacent side, and then my hypotenuse is 13, and now finding the y, which is this one here. Remember now my y in the here is what? It's negative based on this quadrant. So whatever y that I'm going to find in using my Pythagoras theorem, I need to state that it's gonna be the y that I'm looking for. So r squared is equals to x squared plus y squared. Remember, this is Pythagoras. Now my r here, it's 13 all squared is equals to x, it's 5 all squared plus my y squared. Now taking this 13 to the 5 to other side, so it's going to be 13 all squared minus squared, and then square root, and then square root, and then my y is going to be plus or minus of 144. This is still under the square root, sorry, and then the square root of 144, which is the answer from here, is going to be 12. So it's plus or minus 12. But the y that I'm looking for here, it's a negative one. So therefore, y that I'm looking for, it's negative y. That is very, very, very critical and very, very important. So the y that I'm looking for, it's negative 12. Now, let's go straight into answering our questions now. 3.4.1. They're asking me to find the sine of theta. It's very important also the trig ratios. Remember, my sine is opposite over hypotenuse, and cos is adjacent over hypotenuse, and my tan is opposite over I adjacent. Sorry, it's opposite over adjacent. I usually claim it like this: oh heaven, another hour of algebra. But it's up to you. Other people, they use SOHCAHTOA, but I'm not there. So my sine is opposite over hypotenuse. So opposite side here is going to be negative 12 over hypotenuse. My hypotenuse is 13. So this is going to be my answer for 3.4.1. So going to 3.4.2, they're asking me to find the sec theta plus tan squared theta plus 1. Now, what is very important here is also to remember what is sec. Sec is 1 over cos, in this case is theta, which meaning, remember, the normal cos is what is adjacent over hypotenuse, meaning this one is going to be now in hypotenuse over adjacent, which is going to be OR or over x. This is very important because it's a reciprocal of the opposite cos. So that's what is going to happen here. So these others are going to be just be normal. So what is my r? In this case, my r is 13, so it's going to be 13 all over x. What is my x? It's 5, and then plus tan. Remember, tan is opposite over adjacent. So what is my opposite? So it's negative 12 all over my adjacent, which is 5. This is all squared, and then plus 1. And then from there, and the answer here is going to be 2, 3, 4 all over 25. So this is an answer after patching your calculator from there. Hopefully we're still on the same page. Thank you so much, guys, for watching this video. Umakebalo.